The aim of this study was to measure the size of the droplets after they left the nozzle during spray drying. For this experiment, we used 2 high-performance light sources and a high-speed camera capable of capturing up to 7 million images per second at its highest setting. The first test was conducted using water and a lens with 5-fold magnification. The nozzle has an inlet for the liquid, which is supplied by a pump, and a second inlet for compressed air, which is used for atomization. We selected 2 flow rates, 3 and 15 milliliters per minute, and 3 pressure settings ranging from 0 to 5 bar. The results are presented below. If no video is shown in the experimental matrix, the corresponding experiment was not conducted. When pressure is applied, we observe that there are no clear droplets visible, but rather a continuous water film. We then moved on to testing a suspension of aluminum oxide in water, while keeping all other process parameters constant. Here, it is even clearer that the droplets leave the nozzle fully connected, rather than as individual droplets. This is also due to the material parameters of the suspension, such as viscosity and surface tension, which influence the behavior during spraying. For unknown reasons, the suspension seems to have a preference for the right side of the nozzle, even though the nozzle was positioned as accurately as possible in a vertical orientation. If you are curious about the sizes visible in the videos, the diameter of the visible nozzle outlet is 1.2 millimeter. In order to obtain a clearer image of the droplets, we switched to an 8-fold magnification lens and returned to the water system. However, maintaining a clear focus on the droplets was more challenging, as the camera's focus point was on a plane that was difficult to position at an optimal distance. We positioned the focus plane at the nozzle outlet, as this seemed to us to be the ideal focus point, but there were always water droplets in front of the focus plane, blurring the images. We moved to the alumina slurry system again. Even with the higher magnification lens, we were unable to detect individual droplets in the pressurized system, only finding connected water droplets. However, we must emphasize that this is an artificial system and cannot be guaranteed to represent flow states in a spray dryer. In fact, the spray dryer contains more equipment, such as an atomizer, which impacts the flow dynamics. In the final stage, we wanted to find out what happens below the nozzle region. Please note that the top and bottom rows show the same flow rate. For the bottom row, the camera was shifted downwards by 2 centimeters. It was not possible to capture individual droplets due to the difficulty of achieving a good focus. Despite the ultra-bright light source, the images appear dark due to the camera's high shutter speed. The videos you see here have been brightened using software.